going to talk about random and then do a setup session where I apply some of those concepts. Random has a lot of applications, but here I'm going to use it just to introduce some variation, some noise into setups that have multiple samples. Here in Lightwave, I have this object called CubeInstancer, and it has an instance generator with 100 instances. In its node editor, I have some things already set up, and the first thing that I'm going to do is to distribute the instances between object A and object B X position. To do that, I'm going to use the instances ID index that goes from 0 to 99, since I have 100 instances, and I'm going to put that range here in the box tab. So with this, I'm going to have the values normalized into the unit space between 0 and 1. And with those values, I'm going to perform a linear interpolation in the mixer between object A X position and object B X position. The result of that goes into the X channel of a vector, and to that vector I'm going to subtract the base position of the instance, meaning the position that they have at the moment. This because this offset parameter, it's not an absolute position parameter, but a delta. So if I plug this in here, you can see that I have the instances linearly distributed between the two objects. Now, what if I want something with a bit more variation or noise? Well, the common answer to that is to use a procedural texture. Here I have this multifractal with black and white in the colors and with a very small size in the x-axis. So if I plug this in here, you see that indeed I get something that it's a bit more noisy. But at the same time, you also notice that it looks like I lost some instances. Well, I didn't lose them, but the distribution of this multifractal, it's not very uniform. So random is not just about having some funky noise output, but it's also about chance and probability. So if I say that I'm going to get a random value between 0 and 1, I want that all the values between them have the same equal probability of being picked up. In fact, if I start to build up a lot of samples with a good random implementation, I'm going to have a uniform sampling distribution. So there's no big gaps and the values don't cluster, the samples don't cluster around the same values. What I have in here is not that. I have some instances clustering around some values. And so procedural textures are not very good as a source of random. They don't have the value, the values in this range don't have the same chance of being picked up. So let's look into some random nodes. The first one is random by PseudoRandom, and this is a true random implementation, meaning that every time the node is evaluated, I'd get a different value. As you can see, the value keeps updating in the input SPI. So this will produce some funky results. Here it looks all right, but if I turn on Studio Live, and this will make that the node editor is updated or evaluated in real time, you see that the instances start to dance. So this is probably not very useful for things that require some consistency. If I close this scene and tomorrow I open it up, I won't have the instances in the same place. Probably the only context that this node is okay for is for rendering. So if I come here to this camera view and I pick up this surface here called floor with shift click while VPR is active, I have here the random node and it's being fed into all the channels of this vector. You can see that every time the values are always changing and they are all different in all three channels. The random node is set to the range between -1 and 1. So if I plug this here in the bump, you see that I have a reflection blurring effect. If I scale the vector down, let's say to 5, you see that I have less of that effect. If I put this to 50, you see that I have a lot of reflection blurring. Now, one thing is that in this context, the noise that this node introduces, depending on the anti-aliasing settings, it's not going to be noticeable. As you can see, I perform 2 renders, and as I swap between one and the other, you barely notice the changes. So this is a context where this node can be useful for. Let's take this out, go back into texture shaded, and go back into perspective. So let's look into other random nodes. We have these two here, random scalar, which is native, and random, that is in DP kit. These two are pseudo-random node, unlike this one, which is a true random. Unlike this one, these nodes use a value to drive them, and they have consistent output. So for example, if I come here and I place 2 of these, and I have an integer that drives them, you'll see that they output the same thing. Now, because there are different implementations, of course, this one will give me something different. you have to have it set to surface here in order to work in some of the context. But so with this, it means I can plug this, for example, in here, and I won't have the instances dance around with Studio Live, because every time the node evaluates, since it's using this seed to drive its random value, it's always going to give me back a consistent output. You can see the effect of what's going actually on the instances by, for example, coming here, turn on VPR, coming to this surface. And if I plug the instance ID index into a box tab between 0 and 99, and I use it in a mixer to basically do an interpolation between blue and yellow, you can see that I have this distribution with the random. If I use the linear distribution, you'll see that the gradient is also linear. So if I put this here, okay, so this kind of, since the instances have all the same color, this shows a little bit better what happened when you apply a random value between 0 and 1 in the mixer. Now, this random node, it will perform with using the instances ID index, will give me the same values as the fixed random. As you can see, I got the same result. So fixed random is just like the random scalar node, but without, you cannot change the seed of the random value. So while that's okay, sometimes you kind of need to have access to the seed, because this type of node, this type of pseudo-random node, if I start to use the same random scalar into a lot of parameters, I'm going to have a lot of values that are going to match. So let's say that I have this random value go into several places, several parameters. These parameters will have corresponding characteristics because the same random value is used to all of them. So this means that for each parameter, I need to use a different random scalar with a different seed range. Let's look into an example of that here with this plane. So I'm going into the displacement node editor, and here I have my true random node, and you can see that I have a true random vector that keeps updating. And if I plug this in here, you can see that I get this. Of course, if I turn on Studio Live, well, this goes crazy. But so what if I want to get this sort of random vector, but with the pseudo-random? Well, if I apply the same value into all three channels of a vector, you see that I get the same value in all three channels. So unlike this one, where all the channels have a different value, this one will give me the same value. So of course the result is not very interesting. As you can see, doesn't look very random. Now, in order to make this work, I have to have 3 random scalar nodes. And if I use, of course, the same seed, the result will be the same. So it's no use to use different random scalar nodes if I just use the same seed to drive the random value. So I have to offset the seed or do something to it to be different. I can, for example, use a random integer, let's say here, and you can see that the y values already broke the pattern, so that's good. But I cannot, for example, use the same thing for the last one. So if I do this, I'm going to have the same problem. Even though they are different random integer nodes, of course, if I use the same solution for all of them, I have the same problem back again. So this means that for each seed, I have to have a different seed range. So for example, for this one, I can just go with this. For this one, I can go with a random integer, and I can, for example, cascade the random integer nodes. And so with this, I already get something that looks like the true random node. Another way to go about offsetting the seed is to put an add node, scalar add, and to basically change the range of the seed. So for example, I can add 999, and this will give different values here than it will give here. So this is another way to offset the seed range. I can have another 9 in here, and so this will look just like this true random implementation, but without the dance part. Okay, so let's look into another node. This time it's the sequencer. The sequencer is a quasi-random node. So basically it's not trying to do actual random values, but to fill the unit space between 0 and 1 with evenly distributed samples. You can find out more about the way it works here in the DBNW wiki page, where it explains what's the sequence. So if I come here back to this object, and let's see if I plug the sequencer in here, you see that I get this, and the distribution is probably even more uniform than with the random node, as you can see. But in a way, it looks like I have more instances now as well, or even than this one, for example. So while it's not trying to be random, it does look, it has some variation, and it guarantees me that I will not have two values being the same, and also that my samples will be apart from each other in the most evenly way it's possible. A good application for the sequencer is also to generate object IDs. So if I come here to the VPR, and you can see what the sequencer distribution does versus, for example, random scalar. We turn on Studio Live. And so you can see that what it does, very uniform. But if I come here into the surface and let's see, I have this sequence here being fed with the instance info ID index. And if I put the color here in the fuse shading, you'll see that I have these instances having these colors. So what you can also read about it here is that it will do RGB values and exclusively. So this instance is green and it only has a value on the green channel, and the green value that it has, no other instance has it. So it's good to basically use for compositing, where you'll know this instance will have a unique green value. That can be checked, for example, if I use here a split color and the logic node has a threshold, and let's say that here I'm going to check the blue channel, and you can see that as I increase the value of the threshold here, the instances start to disappear. So I'm doing a sweep and you can see that the values are unique. So this concludes this part about random, and let's go into the setup session.